All right. Let's understand what the heck is going on. It says the area of a circle increases at a rate of 20 square inches per minute. At what rate is the radius increasing when the radius is 5 inches? Here's my question to you. Pair and share. If a circle, if the area is getting bigger, what else is changing with the circle? Go, talk. Okay, 5, 4, 3, 2, 1. Shuttle, 5 things that are changing. Yes. Circumference is changing. Diameter. Radius. Time. That's usually the one that doesn't get mentioned. Way to go, Sid. For Sid, 1, 2, 3. Because this is the one that everything is related to. As time goes by, all of those things are changing. And so far what we've been doing is we have been taking the derivative of y with respect to x. That's what we've been doing this whole time when we take derivatives. Today what we're going to do is we're going to take the derivative with respect to time. They are all connected with time. Okay? And so I like to divide these problems up into 4 boxes. I like to write the first box here where I draw what's going on. So we have a circle that's getting bigger. Everybody good with that? Yeah. So the circle's getting bigger, and there's a formula for area of a circle. Can somebody tell me the formula for area of a circle? Very good. Area is pi r squared. Now, what I want you to understand is that which we are trying to find and that which we are given. So if you look at chemistry or physics or mathematics and you look at applications, this is probably the most important part of any of your work, is to understand what am I given and what am I trying to find. Let's start with what we're trying to find. What does the question ask for? The radius is changing. So we're actually looking for r prime. We're looking for the rate at which the radius is changing. What are we given in the problem? A prime is 20. Very good. The rate at which the area is changing is 20. Yeah, we know the current radius at that time is 5. Now, here's something that's really, really, really important for you to know, and probably one of the most important things about related rates, and people make mistakes on this all the time. If they say r is equal to 5, they're like, well, can I plug that in right here, right now? And you can't, because it's changing. Did everybody understand that the radius is changing and so is the area? So therefore, I can't just plug in 5 right now, okay? But I need to come up with an r prime, and right now there's no r prime in here. So in the first box, I like to draw the picture of what's happening, understand it. In the second one, I like to write down the formula that I'm going to use along with the givens and the unknowns. And this box, I like to take my derivative. So we're going to take the derivative with respect to time of area equals pi r squared. I'm only going to do this once so that you can remember what the heck happened, okay? And so don't write this down, but suppose I had y squared plus 1 is equal to x cubed. And we took the derivative with respect to x. Do people remember what the derivative with respect to x of y squared was? We said 2y prime. And the way that we understood that is we said, well, it's going to be 2y, and the y that is gone is going to be absorbed right there. And dy over dx is the same thing as y prime. So that's why I wrote 2y prime. Everybody good with that? And the derivative of 1 was, and then the derivative of x cubed was, and so we said, well, yeah, it's like 3x squared, and that x is going to be absorbed by that top, and dx over dx is just 1. So that's why we got the 2y prime is equal to 3x squared, okay? So, so in this situation, notice that if x is on the bottom, then you can see as it gets absorbed, then it just vanishes, right? But if the variable is different, so in this case, we took the derivative of y squared, it's not a y on the bottom, is it? So you had to attach a y prime. So as you look at this example here, our variable is t. Are there any t's in this problem? No. So we'll always have to attach a prime every time we take the derivative. So what's the derivative of a? 1a prime. What's the derivative of pi r squared? Yeah, you're going to drop the 2 in front, right? So 2 pi r, and then you have to attach a r prime. Yes. So the rule is every time you take the derivative with respect to this variable, you just attach a prime. So now you can see how we come up with the r prime, don't we? So in this last box here, this is where I then solve. I know that a prime is 20. So 20 is equal to, sorry about that, not 5 pi, but 2 pi, times, what is the current radius? 5 times, and then r prime. Or in other words, 20 is equal to 10 pi r prime. Divide both sides by 10 pi. And I get r prime is equal to 2 over pi. And I need to make sure that I write a label. So what are we measuring the radius in? Inches. And it's a rate, so it's inches per minute. So 2 over pi, so it's about 0.6 inches per minute. So that's how fast the radius is changing if the overall area is changing by 20 inches squared per minute. Not too bad, huh? So you saw the y's in all this thing. Let's just get to a basic example of that slightly different. We have a basketball being filled with air at a rate of 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12? Everybody see how this is very similar? Yeah. So I'm going to draw my basketball. I'm going to try to draw kind of a three-dimensional shape. I know it's really bad, but that's all right. It's getting bigger. And what you need in this case is you need the formula for the volume of a sphere, don't you? Yeah, so the volume of a sphere is equal to 4 over 3 pi r cubed. What are you looking for in the problem? Looking for r prime. You are given the current radius, which is 12. And what else are you given? V prime is equal to 1. So I have my information. I'm looking for an r prime. In order to come up with an r prime, I'm going to need a derivative. So I take the derivative with respect to time. Basketball is being filled with a rate of 1. So the derivative with respect to time, v is equal to 4 over 3 pi r cubed. What is the derivative of v? V prime is equal to? Yeah, so you drop that 3 in front. The 3's are going to cancel, right? And you'll get 4 pi r squared r prime. And so v prime in this situation is 1. So 1 is equal to 4 pi times the radius squared. What is the radius? 12. So 144 then times r prime. Yeah, what is 4 times 144? Very good. So 576 pi r prime. Yep, 1 over 576 pi is equal to r prime. 1 over 576 pi what? Yeah. Kind of see the process? So what I expect that you would see on the AP exam is where they would actually give you the formula, because you might not remember the formula for volume of a sphere, correct? Okay. You did. You did. It was geometry. Okay. You cheated your way through the course, so. Yeah. So anyway, so that was that. But notice that all we have to do in that situation is just type in something for r prime, right? That's it. So let's do one more example, and then you're going to try a few problems in your homework. Let's try something that looks a little bit different. But what I would like you to do is I would like you to see if you could just set up the first two boxes. Set up the first two boxes. Okay? Just see what you could come up with. Ready, set, go. Explore. Okay. Good job. Let's see where you got. We got a triangle. Good. And I have certain dimensions of the triangle, and I'm going to put some dimensions in place. The fact is that I have the height of a triangle, don't I? And I also have the base of a triangle. Now, what's interesting in this problem is it says a right triangle has a base of 12 that remains constant. So, true or false? The area is getting larger. True. True or false? The base is getting larger. The base is not changing. And so, therefore, I can just write 12 there. And I'm going to use that to my benefit in a second. And you'll see why it makes such a difference. Now, I need to come up with the area of a triangle. On the AP exam, they most likely will give you the formula for the area of, or the volume of a sphere. They will not give you the formula for area of a triangle. They will say that you know that. Yeah. 1/2 base times height. Good. Okay. We all good? Let's write down some of our knowns and our unknowns. What is our known A prime? A prime is 8. B is equal to 12. What else? We're looking for what? H prime. Excellent. That's so important that you identify. I'm trying to find H prime. We are given something else in this problem. What are we given? Constant area is equal to 64. Constant area of 64.
Yeah, so the one is what try 5.
Okay. Now, hold on. So this is the most important part of this problem that you recognize. If I were to take this derivative right now, what rule would you have to use? The product rule, right? Because you have two different things. Now, just hold on there because we're not going to take the product rule. But suppose we did. You would get A prime is equal to, what would be the derivative of 1/2 B? 1/2 B prime, good. Times H plus 1/2 B times, what's the derivative of H? H prime. So notice if we did the product rule, notice what you have here. You have a B prime that pops up, but yet we don't know what B prime is. We have, you're good. You'll end up having to just walk out and figure something out. Yeah. I've got solutions for you. So anyway, so notice how you come up with a B prime. We have no way of finding B prime. And so this is why we get to use this piece. Okay? Does B ever change? So just plug it in. Does A change? Yes, the area is changing. So you cannot plug in 64 for A, but you can plug in 12 for B. Do people understand that? The area is getting bigger, but the base is staying the same. So therefore, you can plug 12 in it at this time. We get area is equal to 6H. Great. I can take the derivative of that. That's easy. Derivative with respect to time of a equals 6h. What is the derivative of a? A prime equals, what's the derivative of 6h? 6h prime. Now I could try to solve.
It's not 6, if it was 6x, it would just be 6.
Yes, no, well, if it was 6t, then it would be 6. Okay, what is a prime? 8 is equal to 6 times h prime. Did I ever even need to know that the area was 64? Didn't come up in the problem. It is there to be there. I divide by 6 and I get 4 over 3 is equal to h prime. Or h prime is 4 over 3. What is my measurement? Centimeters per second. Grab your homework.